We have reached the last part of our logs and exponential unit. Woohoo! We're going to talk about applications. There are many applications of logarithmic and exponential. One of the most popular is talking about compounded interest. For any of you guys taking personal finance, that probably will come up. It's also something that we see on the SAT and PSAT somewhat regularly. So we have a formula, and this is used in the banking industry, as you might expect, for interest and investments, figuring out how much you're going to make by putting it in an account. A is the balance in the account currently. P is the principal. That's how much you started out with. So let's say you put $1,000 into a bank account. That's your principal. R is the annual interest rate, and that is usually in decimal form. N is the number of compoundings per year. So if it's compounded monthly, then N is 12. And T is the time in years. So let's say you let it sit for 5 years, T would be 5. So we use our exponentials to help us understand and utilize this application. Here they're going to develop the formula. I'm not going to ask you to develop the formula. I'm just going to ask you to understand that it is exponential, because as you apply that interest, it is always multiplied by that same amount every time that the interest is applied. So we have something raised to the nt. There's your exponential. And what happens here, the r over n is your rate divided by the amount of times per year that's happening. Now, if you have continuous compounding, then we're not going to use exactly this formula. So here is where they're taking you from the regular formula and showing you what happens as we change the number of compoundings. As we increase the number of times that interest is earned, that ratio approaches E. So as M gets bigger, the number of times, we use E. And so you'll see this formula is being used. Let me grab a little pen here. You'll see this formula for continuous compounding. A equals P times E to the RT. And that most certainly looks exponential. So if you have N numbers of compounding per year, like monthly, quarterly, daily, you want to use the first formula. If it's compounded continuously, you want to use the second formula. So here's an example. You take $12,000, you put it in an account. It earns 3% every year. But in each of these scenarios, the interest is applied in different ways. In A, you get a quarterly interest payment, so 4 times a year. In B, you get a monthly interest payment, so that's 12 times a year. And in C, it's continuous. But it's definitely a little bit more. It's about $5 more. But they use the 12. When they do it continuously, this is the biggest amount. You make more the more they apply the interest. Now for logarithms, you see a lot of logarithmic models in medicine. This one is talking about the human memory model, a psychology type thing where they're studying the memory in human beings. And they're talking about scores to see how much they remember of the material. And this is a model that they came up with. where t is time in months. And they said, what was the average score on the original exam when t is equal to 0? How about after 2 months or 6 months? And so what they're going to do is they're going to evaluate at those times. Evaluate at 0, you're going to get the 75. When you evaluate after 2 months, they're scoring lower than 75 because they forgot some stuff over time. And after 6 months, even lower because it's been 6 months. Now, as far as solving equations, was it 3? No, it was 6.75. Pardon me. So that's what it's going to do. It's going to take them a little over 10 years to double that money.